Today we're going to review original Sohcahtoa and right angle triangle calculations. Tomorrow we'll go and talk about multi-step equations. So first we're going to talk about Sohcahtoa. When we're dealing with Sohcahtoa or sine, cos, and tan triangles, we're dealing with right angle triangles. And you notice with every right angle triangle we have a reference angle. Now, with that reference angle we have an adjacent side and an opposite side, as well as a hypotenuse. Now, the only important angles for any right angle triangles are any angles that are not 90 degrees. The only reason we have a 90-degree angle is because we need to notice that we can use the Sohcahtoa or the Pythagorean theorem to solve for the sides of the triangle. Now, for the next portion of this triangles that we're looking at, this time the angle is at the top, so we need to still identify the opposite, the adjacent, and the hypotenuse. And this is just an alternative way we can label the triangle. Quickly reviewing Sohcahtoa. When we're dealing with sine, we're talking about sine of A or theta is equal to opposite over hypotenuse. When we're discussing cosine of theta, we're talking about the adjacent divided by the hypotenuse. When we're talking about the tan, we're talking about the sides of the triangle, the actual legs, and the legs, otherwise known as the opposite over the adjacent. When using the primary trig ratios, we have to identify the important angle, the given or needed, whether it's given or needed, and then identify the sides, whether they are given or needed, and then choose the sine, cos, or tan to solve the ratio. So now we're just going to go over some sample problems. After doing these three examples, I expect you to work on the sheet I give you, and it's question number 2. In question A here, it asks us to solve for the variable indicated. In this case, we're solving for x. But if you notice, we also have a hypotenuse here. We don't rather know if this is the adjacent or the opposite. In this case, we're going to use this angle here as our reference angle, 47. So this means this is the adjacent and this is the hypotenuse. Now, because we're using our favorite word, Sohcahtoa, to help us to determine whether we're using sine, cos, or tan, you'll notice that the two sides that we have are the adjacent and the hypotenuse. Sitting beside are 47. So in this case, we're going to use cosine. So we have cosine of 47 is equal to x over 15. The rule for solving for x when x is on the top of the fraction is just take cosine of 47 and 15 and multiply them together to get x is equal to 15 cosine of 47. And we end up with x is equal to 10.2 centimeters. For the second problem, we have an angle, we have a side and another side that we're looking at. In this case, 32 is our reference angle, D is our hypotenuse, and O is our 6.8. Based on Sohcahtoa, we're going to use sine in this case. We have sine of 32 is equal to 6.8 divided by D. Since d is on the bottom of the fraction, in order to solve for d, we're actually going to have to take 6.8 and divide by sine of 32. We can show the result by actually doing cross multiplication. Putting a 1 under sine of 32 allows us to do the cross multiplication. Remember, cross multiplication just links the bottom and top of the opposite sides together in the form of multiplication. So we'll have d sine 32 is equal to 6.8 times 1, which is just 6.8. Finally, to get d by itself, we divide both sides by 32, and we end up with the following result, for which we have d is equal to 12.8 meters. For this last problem, you'll notice we have a reference angle, which we don't know, and we have two sides. In this case, the adjacent is 8.4, and the opposite is 12.5. So since we only have two sides, opposite and adjacent, we're going to have to use tan. So now we have tan of theta is 12.5 over 8.4. In order to find theta, we have to use the inverse of the fraction of tan on the other side here. So what I'm actually saying is something that looks like this. Theta is equal to tan inverse of 12.5 divided by 8.4. You'll notice that we have put this entire fraction in brackets. We must put the entire fraction in brackets when we do our calculation on our calculator. If you don't do that, the problem will not be calculated properly. In this case, when you do tan inverse of 12.85 divided by 8.4, you're going to get theta is equal to 56 degrees. When you do your calculations, please leave your angles to whole units, no decimals, please. Make sure you round them up properly as well. Now, what I'd like you to work on for this latest problem set is going to be from the worksheet. You're going to work on number 2. Thanks. When we're talking about solving a triangle, we really mean find all the missing information. To find this angle, we're going to have to use the internal angles of a triangle, which is 180 degrees, minus the 70 and the 90 to get a total of 20 degrees. Now, once you've got your 20 degrees, fill it in. From here, you'll notice that we have two sides that are missing. We have this side and this side. I will call this side X and this side Y. In order to find X, what I'm going to use is I'm going to use Sohcahtoa. And I'll notice that for this side and this side, this is my adjacent, this is my opposite. So now what I'm going to use is I'm going to use tan to find X. Since X is on the top of the fraction, all we have to do is just multiply tan and 6.8 to get approximately 2.4. Now, to find the final side, before you do that, you got to make sure that you label your side that you found out. And then what I need you to do is use Pythagorean theorem to find the other side, or you could use sine, cos, or tan again. I choose to use Pythagorean theorem, where we have y squared equals 6.8 squared plus 2.4 squared, which is just equal to 52. When we square root 52, we end up with y being approximately 7 0.2 meters, which is what we expect. And go back and fill out your triangle. And we're done. You'll notice that this problem just describes a triangle here. It says triangle PQR, where P is 90, Q is 7, and little p is 10.3. So what we're going to do, the moment we notice that it's a 90-degree triangle, we're going to draw a right triangle. And here is my right triangle, not drawn very well. P, and each corner is one portion of the triangle. So we're going to call this P, Q, and R. We only know that angle P is at 90 degrees. We know that this side here is side P, and we'll notice that it is 10.3 centimeters. You'll also notice that the problem states that Q is 7.0 centimeters. So Q is directly across from Q. Little q is directly across from Q, so we're going to label that and write it down right now. And that is 7.0 centimeters. Now every time I do these problems, I tend to take the time and write Sohcahtoa to remind me what I'm going to use for this right angle triangle. In this case, this side of my triangle, I'm going to use one side of the triangle referenced by R. Now, this side here is my adjacent, and this side here is my hypotenuse because it's directly across from my right triangle. So I have my adjacent and hypotenuse. So we're going to use cosine. So we're going to find the angle R. So let's do that right now. So cosine of R is going to be 7.0 divided by 10.3. And now what we're about to do is we're about to solve for R. To solve for R, we take the cos inverse of the fraction on the right side, and we'll get the following answer. Angle R is equal to 47 degrees. Once you've got your 47, write it on the triangle. Then what you need to do is find the other side. So for angle Q, when you calculate it, it's going to be, angle Q is going to be 180 minus 90 minus 47, which is 43 degrees. And finally, we could use Pythagoras' theorem to find this side, or we could use sine of 10.3, or we could use tan. So I'm going to use tan in this case. Upon calculating, we find that R is approximately 7.5 and centimeters. And make sure that you label it on your triangle, please. So here's my angle of 43, and my other side is 7.5 centimeters. And we're done. So what I need you to do is I need you to work on the homework that I've handed out to you. It's page 2. It's number 2 and 3. You need to do at least 2 parts of each of them. Thanks. I should note that we are going to have a test on this in about 2 days, or possibly 3.